What is the scariest theory you have ever read about the universe? Story 1. The false vacuum idea is terrifying because it says the universe might be calm by accident. The way the theory goes, space-time itself could be sitting in a metastable energy state, not the lowest possible one, just a comfortable plateau, like a dammed lake that looks permanent until something cracks the wall. Everything works. Physics behaves. Particles have mass, forces balance. Reality feels solid, but it might not be final. If a sufficiently energetic event ever pushed a region of space-time over the barrier, quantum fluctuation, extreme energy concentration, something we don't even know how to name yet, the vacuum could decay into a lower energy state, and that transition would release energy. A lot of it. Enough to fuel the same transition in neighboring space-time, a chain reaction. Not an explosion you'd see coming, not a shockwave you could outrun, just a bubble of new physics expanding at the speed of light, rewriting the rules as it goes. Inside it, particles wouldn't behave the same. Atoms might not exist. Chemistry might not be possible. You wouldn't feel pain or fear or surprise, because those concepts would stop making sense before your brain could register them. What makes it uniquely horrifying is the scale and the indifference. There's no warning, no blame, no survival strategy. The universe doesn't end. It changes state, like water freezing. And everything that relied on the old rules simply fails to continue. The dam doesn't burst dramatically, it just stops holding. And the most unsettling part, if this theory is true, it could happen tomorrow. Or it could already be on its way, crossing the cosmos invisibly, and we'd never know until there was nothing left to know it with. Story 2, if you had a soda straw 8 feet long and held it up to the night sky, and if your eyes were good enough, you'd see something that breaks the brain. Through that tiny circle of darkness, you wouldn't be looking at stars. You'd be looking at about 10,000 galaxies. Each one is a city of stars, billions of suns, planets, time, history, entire systems living and dying so far away that their light has been traveling toward you since before humans existed. That tiny patch of sky you casually ignore, it's packed, over full. There is no empty direction. What makes this unsettling isn't the number, it's the implication. That straw-sized view is meaningless to the universe. You could point it anywhere, and get roughly the same result. Reality isn't sparse. It's saturated. Space doesn't feel empty because it is. It feels empty because our senses are hopelessly outmatched. And none of those galaxies are aware of you, just like you aren't aware of most of them. We like to imagine ourselves looking out into space. But facts like this flip the perspective. You're not peering into the universe. You're standing inside something so vast and crowded that even a pinhole view contains more worlds than your mind was built to hold. The sky doesn't look back, but it's never been empty, and it never needed us to notice. Story 3. Just the mind-boggling size freaks me out sometimes. All of the planets of the solar system can fit between the orbit of Earth and the Moon, with about 5,000 miles to spare. The distance between Earth and the Sun is about 390 times larger than the distance between Earth and the Moon. The distance from the Sun to the Oort cloud, outer edge of the solar system, is about 1,000 times larger than the distance between Earth and the Sun. To get to the outer edge of the Oort cloud, you have to travel that distance 10 times. And guess what? If you do all that traveling, you've gone a whopping 15% of 1 light year, which means only 24 more of those trips, and you finally reached our closest neighbor, Alpha Centauri. I hope you brought a good book. Story 4. Gamma ray bursts are terrifying because they don't aim. They just erase. Somewhere in the universe, a massive star collapses, or 2 neutron stars collide, and for a few seconds the event releases more energy than the sun will emit in its entire lifetime. All of it focused into a narrow beam, not light you can see. Radiation so intense it strips atmospheres and sterilizes planets from across the galaxy. If one were aimed directly at Earth and close enough, you wouldn't get a warning. No flash, no sound. The upper atmosphere would be shredded first. Ozone, gone. Radiation flooding down. Life ends not with impact or fire, but with chemistry failing all at once. What makes GRBs uniquely unsettling is the randomness. They're rare, but not impossible. They don't care about intent, intelligence, or preparedness. They don't need to hit you directly to ruin everything. Just being close enough is sufficient. And the worst part? You'd never see it coming. The burst travels at light speed. By the time the photons arrive, the event that caused them is already over, and so is any chance to react. No monster, no apocalypse movie drama, just the universe briefly pointing a cosmic weapon in your direction and pulling the trigger. Gamma ray bursts are a reminder that survival isn't always about mistakes. Sometimes it's just about not being in the beam. Story 5. Magnetars are terrifying because they don't need to be close to matter. They're neutron stars with magnetic fields so strong they don't just bend physics. they rewrite it. A magnetar flare can release more energy in a fraction of a second than the sun does in hundreds of thousands of years, blasting out high-energy radiation that doesn't care what's in the way. Earth has already been hit by one of these, back in 2004. The source was about 50,000 light-years away, and it still disrupted Earth's ionosphere. Satellites noticed, instruments flinched, and that was from halfway across the galaxy. The closest known magnetar is only 9,000 light-years away. What makes that unsettling isn't panic, it's scale. If a magnetar in our neighborhood released a major flare pointed our way, it wouldn't crack the planet or knock us off orbit. It would do something quieter and worse. Overwhelm electronics, damage satellites, scramble communications, and bathe the atmosphere in radiation we have no way to shield against. You wouldn't see it. You might not even notice immediately. Systems would just start failing in clusters, for reasons no one could fix fast enough. Magnetars don't hunt planets. They don't aim with intent. They just occasionally remind the galaxy how fragile technology is and how little distance sometimes matters. Story 6. The Fermi paradox is scary because the math says we shouldn't be alone, and the sky says we are. Hundreds of billions of galaxies, trillions of stars, planets everywhere, chemistry that repeats itself reliably. Given enough time, intelligence should emerge over and over again. Civilization should rise, spread, leave traces. The universe is old enough that some should be unimaginably ancient. And yet, nothing. No signals, no probes, no ruins, no megastructures blotting out stars. Just silence, deep and uninterrupted, no matter how carefully we listen. The paradox isn't why haven't we met aliens, it's why the universe looks untouched. That's where it gets unsettling. Either intelligent life is extraordinarily rare, or something reliably wipes it out before it spreads. Or it chooses to stay quiet. Or it learns something we haven't, and silence is the point. The sad part is imagining a universe full of potential that never quite crosses the finish line. Civilizations flickering briefly, then gone, one by one, without ever knowing they weren't alone. The scary part? We don't know which stage we're in. The universe feels vast and welcoming when you look at the stars. The Fermi paradox makes it feel like an empty room, and you can't tell whether you arrived early or late. Story 7. When Stephen Hawking talked about the Higgs field possibly dooming the universe, what made it chilling wasn't drama. It was mechanics. The idea is simple and awful. The Higgs field might not be in the lowest possible energy state. It could be metastable, stable enough to last billions of years, but not truly secure. If some extreme event nudged it over the edge, the field could collapse into a lower energy configuration. Physics would change instantly inside that region. And then it would spread, not like an explosion you see coming, like a phase change. A bubble of new reality expanding at the speed of light. No warning, no shielding, no reaction time. Inside the bubble, particles might not have mass the same way. Atoms might not bind. Chemistry, and therefore life, would simply stop being possible. What makes this uniquely horrifying is the timing problem. Because nothing can outrun light, if it happened far away, we wouldn't know until it arrived. The universe could already be transitioning somewhere beyond our horizon. And from our perspective, everything would still look fine. No countdown, no omen, just now, and then not now. Hawking didn't say this to scare people. He said it because the equations allow it. Unlikely? Probably. Impossible? No. The most unsettling part isn't that the universe could end. It's that if it does, it won't feel like an ending at all. Just a boundary we cross without ever seeing it approach. Story 8. Time dilation is unsettling because it means time isn't shared. Two perfect clocks. Both work flawlessly. No signal delay, no trick. And yet, if one moves fast enough, or sits deeper in gravity, it will tick slower, not appear slower, be slower. When the observers reunite, they won't just disagree about measurements. They'll disagree about how much life happened. That's the part that gets under your skin. This doesn't come from engineering flaws or perception. It comes from space-time itself, from the geometry of reality. According to Albert Einstein, time is woven together with space, and motion through one changes how you experience the other. There is no universal now keeping everyone in sync, which means the universe doesn't age uniformly. Astronauts return slightly younger. GPS satellites must constantly correct for it or your phone would drift miles off target. Near black holes, time nearly stops compared to the rest of the universe. Not metaphorically, literally. What makes it disturbing isn't the math, it's the implication. There is no single timeline everyone shares, no master clock ticking in the background. Your present isn't aligned with someone else's present, except approximately and temporarily. Reality doesn't move forward together. It shears. And once you really internalize that, the idea of a clean, orderly flow of time quietly dissolves, replaced by a universe where when you exist, depends on how you exist. Story 9. Because the universe is expanding, there will come a time when the night sky goes dark. Not cloudy, not light polluted, empty. Galaxies are already rushing away from each other, carried by the expansion of space-time itself. The farther they are, the faster they recede. Eventually, everything beyond our local group will slip past a horizon where their light can no longer reach us. Not because it's dim, but because space is stretching faster than the light can cross it. Future observers will look up and see only their own galaxy. No Milky Way spiraling across the sky. No Andromeda. No deep field specks hinting at scale. Just a handful of nearby stars in a black void. What makes this sad and quietly horrifying is that those future civilizations won't even know what they're missing. With no distant galaxies visible, they'll have no evidence the universe was ever larger, richer, more crowded. Cosmology itself becomes impossible. The Big Bang becomes unknowable. Expansion becomes unprovable. The universe won't end with fire or collapse. It will end with loneliness, stretched so thin that even evidence of others disappears. We happen to live at one of the only moments when the universe still shows itself. The stars haven't gone yet. The galaxies are still visible, which means the night sky isn't just beautiful, it's temporary. Story 10. The idea that it might all be a simulation is unsettling because it reframes everything without changing anything you can touch. The argument, popularized by Nick Bostrom, isn't sci-fi fluff, it's statistical. If intelligent civilizations tend to create simulated realities, and if they create many of them, then any given conscious observer is far more likely to be inside a simulation than in the original base reality. Nothing breaks. Physics still works. Pain still hurts. Love still matters. That's the trap. What makes it scary isn't the idea of being fake. It's the idea of being conditional. That reality could be paused, copied, rewound, shut down for reasons that have nothing to do with us. That the universe doesn't end in fire or darkness. It ends when someone gets bored, or curious, or flips a switch. And there's no test that conclusively proves we aren't in one. Any evidence you'd point to could itself be simulated. Any law of physics could just be a rule in the engine. You don't lose meaning in a simulation. You lose guarantees. No promise that the universe must continue. No assurance that causality is fundamental. No certainty that reality exists for its own sake. If it is a simulation, then everything you've ever known is still real to you. It's just not real for the reason you thought. And the most uncomfortable part? Nothing about your day would change at all. Story 11. What really messes with your head is that everything you've ever seen barely counts. The sun. Earth. Every star, planet, nebula, galaxy, cluster, and supercluster. All of it together makes up only about 4 to 5% of the observable universe. That's not an estimate drifting around the edges. That's the accepted number. The other 95% is invisible. Dark matter doesn't emit light, absorb it, or reflect it. We don't see it. We infer it from gravity. Galaxies rotate too fast. Clusters hold together when they shouldn't. Something massive is there, sculpting the universe like an unseen framework, and we have no idea what it actually is. Then there's dark energy, which is even worse. It isn't pulling things together, it's pushing everything apart, accelerating the expansion of the universe, overcoming gravity on cosmic scales. We don't know where it comes from, what it's made of, or whether it's constant or evolving. What's unsettling isn't ignorance. That's normal in science. It's that our best theories of reality only describe the minority of what exists. Most of the universe isn't just unexplored, it's fundamentally unaccounted for. We live inside a cosmos where almost everything that matters to its behavior is something we can't see, touch, or explain, yet it completely controls the fate of everything we can. The stars feel eternal when you look up, but they're just surface details floating in something far larger, darker, and still unnamed. Story 12. That's a fantastic nerd scary story, because it's true in principle. A sufficiently large asteroid wouldn't need to hit Earth to ruin everything. If it passed close enough on the right trajectory, its gravity could act like a cosmic crowbar, a slingshot. Just enough of a nudge to change Earth's orbital energy. Not dramatically, not all at once, just enough. Orbits are balances, not rails. Earth stays where it is because velocity, mass, and distance line up just right. Disturb that balance and you don't get fireworks. You get drift. A slightly higher energy orbit and Earth could slowly spiral outward, eventually escaping the sun's grip entirely. No impact. No apocalypse movie moment. Just the planet quietly becoming an interstellar object. The truly horrifying part is the timescale. Nothing would look wrong at first. The sun would still rise. Seasons would still happen. But years would stretch. Temperatures would slide. Ice wouldn't melt in spring the way it used to. Crops would fail for reasons no one could immediately point to. By the time we realized what happened, we wouldn't be able to fix it. Halloween is a perfect time to hear that story, because it flips the usual fear. We worry about asteroids as bullets, but orbital mechanics says the scariest ones are the ones that miss and take the future with them. Story 13, Gamma Ray Bursts. A narrow beam of intense radiation released during a supernova or hypernova as a rapidly rotating high-mass star collapses to form a neutron star, quark star, or black hole. How intense is it? Well, a typical burst releases as much energy in a few seconds as the sun will in its entire 10 billion year lifetime. Pretty hardcore, right? But we detect them pretty regularly, so why is it scary? Well, the GRBs we detect are usually billions of light years away, not in our own galaxy. If there is a gamma ray burst in our own galaxy and the burst is pointed at Earth, we are toast. The people on the side of the Earth facing the GRB can expect radiation sickness and pretty quick death. The people on the opposite side of the Earth can expect a major dose of radiation, but they will probably live long enough to realize the ozone layer has been stripped away and that everything on Earth is going to die pretty soon. And there's no advance warning. Story 14. If black holes don't scare you, then nothing about the universe is going to. Although black holes are pretty damn scary if you're near one. I feel like a lot of the fear is simply from misconception. Please correct if I'm wrong, I'm not a physicist. People often believe that black holes simply sucks up everything around them and destroy everything. While this is partly true, the truth is that if you were, let's say, 10,000 kilometers from the center of a planet that is composed of gas, you would experience the same gravitational attraction if that gas was compressed into a black hole. For example, if the sun became a black hole, all the planets would still orbit as they normally do. Density doesn't matter, distance from the center and mass matter. Story 15. At some point, the universe didn't exist yet. That sentence alone breaks something in the brain, because it uses words that assume a before. But before only works if time already exists, and time is part of the universe. So when you ask what came before, you're standing on a concept that hadn't been invented yet. Was there nothing? Nothing doesn't really work either. Nothing implies absence within a place. But space itself didn't exist. There was no container for nothing to sit in. No background. No darkness. Darkness is still something. You need space for it to be dark in. So where was this nothing? There was nowhere. That's the part that gets unsettling. The universe didn't expand into emptiness. It didn't ignite inside a void. Space itself came into being along with time, matter, energy, and the rules tying them together. Asking what was outside is like asking what's north of the North Pole. It's a direction that stops making sense. Some theories talk about quantum foam, vacuum fluctuations, cycles, or multiverses. Others say the question itself is malformed, not unanswered, invalid. Reality didn't begin somewhere. It began by inventing somewhere. And the most uncomfortable implication? If existence can start without a place to start in, then nothing isn't stable, which means the universe happening at all might not be a miracle. The miracle might be that it hasn't happened again. Story 16. Heat death is terrifying because it's quiet, and because it wins by default. No explosion, no collapse. No final catastrophe anyone witnesses, just the universe slowly, patiently running out of difference. Energy spreads out. Temperatures even out. Stars burn their fuel and go dark. New stars stop forming because the raw material is too thinly dispersed to ever clump again. Eventually, there are no gradients left. Nothing hotter than anything else. Nothing moving because there's nowhere left for energy to go. Time keeps passing, but nothing meaningful happens. Black holes linger the longest, slowly evaporating via Hawking radiation over absurd timescales. Trillions upon trillions of years later, even they're gone. What remains is a universe filled with extremely low-energy particles drifting in near perfect uniformity. No structure, no chemistry, no observers, no events worth calling events. What makes heat death uniquely unsettling is that it doesn't feel like an ending imposed from outside. It's entropy doing exactly what it's supposed to do. The universe doesn't fail, it succeeds at becoming boring. There's no last moment, no final thought. Just fewer reactions, fewer interactions, longer waits between anything at all, until waiting stops meaning anything because nothing ever happens again. Heat death isn't the universe dying violently, it's the universe forgetting how to change. And the most haunting part? Nothing has to go wrong for it to happen. Story 17. The sun burning out isn't a sudden apocalypse. That's what makes it worse. Long before it ever goes out, it changes. Slowly at first, brightening, heating, pushing Earth's climate past anything we could adapt to. Oceans boil away. The atmosphere thins. The planet becomes sterile while the sun still looks calm in the sky. Life ends not with a bang, but with a long, merciless fade. Then, billions of years from now, the sun swells into a red giant. It will grow so large that Mercury is gone, Venus is gone, and Earth might be swallowed, or left just outside, cooked into a molten, airless rock. The sky will be filled by the sun itself, enormous and unavoidable. Only after all that does the sun finally shed its outer layers and collapse into a white dwarf, a hot, dense ember slowly cooling in the dark. No warmth, no light worth calling daylight. Just a dead star where a life-giving one used to be. What makes this hard to sit with is that it's inevitable. No asteroid defense, no technology, no clever workaround changes stellar physics. The sun doesn't betray us, it simply ages. And one day, far beyond anyone alive now, but absolutely guaranteed, Earth's longest relationship ends, and the planet learns what space really feels like without something burning for it every morning. Story 18, Black Holes. They literally gave me nightmares. I remember when I got my first science textbook back in 4th grade, and when I was skimming through, I came across our solar system. I became so obsessed with space from that point on that even today, it's my dream to go aboard the International Space Station and just float around. Anyway, so I'm finished reading about our solar system, and I move on to the next page where it begins to talk about black holes in great detail. For about 2 weeks after reading about them, I would have nightmares about a black hole showing up undiscovered by NASA and proceeding to swallow the Earth. Story 19, a vacuum metastability event. As I understand it, this is QFT stuff, so what the hell do I know? It's the idea that our universe, or pocket of space, appears to have the lowest possible energy state. But in reality, it's not the lowest possible. A metastability event is one where some condition is reached, where there is now a lower energy state, and that changes how particles react on a basic level. This effect spreads out from its source at nearly the speed of light, fundamentally changing the universe as it goes. Forget the basic chemistry that our bodies work on. The particles wouldn't even exist in their correct form anymore. Something else would appear in its wake. I guess you could take some comfort in leaving a corpse that is all new sorts of particles that nobody has ever seen before. Not that any of us would be around to study this new existence, having all been immediately killed by the lack of the physics we need to exist. Story 20. Yeah, that feeling never really goes away once it clicks. You watch one of those size comparison videos and it starts innocently enough. Earth, Jupiter, the sun, manageable. Then the sun gets swallowed by stars with names that sound made up. Betelgeuse, Antares, UI Scuti, and suddenly the thing that defines the day for us is just a rounding error. And that's still just stars. Then zoom out again. Our solar system is a dot inside the Milky Way. The Milky Way is one of billions of galaxies. Galaxies group into clusters, clusters into superclusters. Vast filaments and walls stretching across hundreds of millions of light years. Entire regions of space shaped by gravity on scales the human brain was never designed to picture. And the universe isn't static while all this exists. It's expanding. Constantly. Every distant galaxy is carried away from every other one, not because they're moving through space, but because space itself is growing between them. There's more everything tomorrow than there was today. That's where it gets both humbling and eerie. We're not just small, we're temporary. A speck of dust, yes, but a thinking speck. Alive at a moment when the universe is still young enough to be visible, structured enough to be understood, quiet enough to be contemplated. And then you add the last layer. Maybe this universe isn't even the whole story. Maybe it's one bubble in a foam of universes, each with their own rules, scales, and histories. At that point, speck of dust almost feels generous. But somehow, improbably, that speck gets to look out, measure, wonder, and feel blown away by the size of the thing it exists inside, which might be the strangest part of all. Story 21. That aliens are statistically likely to be arthropods. That's spooky, man. Giant, intelligent spiders. The creepy part isn't giant spiders by itself. It's that the idea actually has teeth. Arthropods already dominate Earth by every practical metric. Numbers, biomass, adaptability, ecological niches. They thrive in heat, cold, darkness, and pressure. They scale well, they're modular, lose a limb, keep going. Their bodies are efficient, redundant, and brutally practical. If intelligence is just another survival strategy that emerges given enough time and pressure, there's no reason it has to look like us. Mammals are fragile, soft tissue, narrow temperature ranges, long development times. Arthropods are the opposite. Exoskeletons, distributed nervous system, compound eyes that see motion better than detail, chemical communication instead of sound, entirely different assumptions about what a mind even needs to be attached to. Which means if aliens are common, and if evolution elsewhere follows the same whatever works best survives logic, then yeah, statistically something arthropod-like starts to make uncomfortable sense. Not humanoid philosophers, not little green engineers, more like intelligence that doesn't blink. Don't sleep the way we do. Doesn't read faces or voices the way we expect. Something that evolved in swarms, colonies, hives, where individuality matters less than function. The real spook isn't imagining giant spiders. It's imagining intelligence that doesn't share any of our social instincts, emotional cues, or body language, and never needed to. Not hostile, not friendly, just other, and very, very good at surviving. Story 22. That we are completely and utterly, incomprehensibly, unfathomably insignificant. We don't matter one single bit in galactic terms, let alone universality. On galactic scales, we're not late. We're not early. We're not even noticed. One species on one planet orbiting one average star, tucked into a spiral arm of one galaxy among hundreds of billions, most of which will never ever know we existed. The universe doesn't register our wars, our art, our extinctions, our triumphs. Stars live and die without us. Galaxies collide without consequence. Physics rolls on, perfectly content to never check whether anyone's watching. That kind of insignificance can feel crushing, like nothing you do could possibly matter if the backdrop is that large. But here's the quiet twist that keeps it from being pure despair. Meaning was never something the universe handed out. Significance doesn't scale upward, it scales inward. In cosmic terms, nothing matters, not just us. On those scales, even galaxies are temporary ripples. But inside our tiny bubble of awareness, things matter intensely. Pain matters. Love matters. Curiosity matters. The fact that a piece of the universe became complex enough to look back at itself and feel awe, that's rare, even if it's small. We are insignificant to the universe. But the universe, vast and indifferent as it is, only knows it exists through things like us. We don't matter because we're big. We matter because, against all odds, we're here at all, thinking about our own unimportance and still choosing to care. And that might be the most human thing possible. Story 23. The fact that it's so freaking close. Gravity, a force we don't even really understand, is the only thing holding on a thin layer of air shielding the entire planet from a vast vacuum of nothingness. Have you ever tried to hold on to air? It's hard to do. Even the Earth doesn't do it perfectly. A little bit bleeds off here and there, too much bleeds off, and we're Mars. But that's not the scary part. All you have to do is swim up a few dozen miles, if you could, and suddenly there's nothing but you and 250,000 miles of emptiness until you hit the moon. At normal human pace, that's like 10 years of drifting through absolutely nothing until you get there. And if you miss that, you just keep drifting, and you'll be drifting for the rest of your life. To me, the scary thing isn't what's in the universe. It's how much there isn't. Story 24. The quantum stuff. Things are made out of stuff that universal law says we can't understand. Also, it doesn't exist sometimes, or something. Yeah, the quantum stuff is unsettling because it breaks the deal we thought reality had with us. At everyday scales, things exist. They have positions. Causes lead to effects. Stuff is made of smaller stuff, but it's still stuff. Quantum physics politely nods at that intuition, and then immediately takes it apart. At the quantum level, particles don't behave like objects. They behave like probabilities. They don't have positions until they're forced to pick one. They don't travel along paths. They smear out into waves of maybe. Sometimes they act like particles, sometimes like waves, and sometimes like neither, depending on how you look. And yes, sometimes they don't exist in the way exist usually means. Virtual particles pop in and out of existence. Fields fluctuate even in absolute vacuum. Cause and effect get fuzzy. Two particles can be linked so tightly that changing one instantly affects the other, no matter how far apart they are, without anything traveling between them. The math works. The predictions are flawless. Your phone depends on it, but understanding it, that's where we hit the wall. Quantum mechanics doesn't just say reality is weird. It says reality has no obligation to be intuitively understandable by creatures evolved to throw rocks and recognize faces. Things aren't made of tiny solid beads. They're made of rules and probabilities, and fields that only become real when something interacts with them. So when you say it doesn't exist sometimes, you're not wrong. It exists as potential until observation forces a decision. Reality, at its foundation, isn't a thing. It's a set of options constantly negotiating with itself, and we only ever see the outcomes, never the process. Which means the universe isn't broken. It's just running on a level of abstraction we were never meant to intuit, only to glimpse, calculate, and quietly be unsettled by. Story 25. The fact that if aliens ever did visit us, it would be closer to what happened when the white man came to America than them wanting to help us. We on Earth would be the Native Americans. That thought is scary because it's grounded in history, not sci-fi. When technologically unequal civilizations meet, it almost never looks like cooperation between equals. It looks like misunderstanding, exploitation, and collapse. Often without malice, just momentum. The more advanced side doesn't need to be cruel. It only needs to exist in the same space. From that lens, aliens visiting us wouldn't be mentors or saviors. They wouldn't need our resources or our permission. They wouldn't share values, ethics, or even assumptions about what a society is. Their biology, psychology, and time horizons could be so different that our survival might not even register as a consideration. Just like history on Earth, the damage wouldn't necessarily come from violence first. It would come from exposure, knowledge shock, ecological disruption, cultural collapse, the sudden realization that you are not the center of the world you thought you understood. And the worst part of the analogy, the Native Americans didn't lose because they were foolish or weak. They lost because they encountered something asymmetrically powerful and unprepared for restraint. That's what makes the alien scenario unsettling. Not that they'd hate us, but that they wouldn't need to care. We'd be fascinating, useful, irrelevant. All options are bad from the smaller side of the equation. It reframes the Fermi paradox too. Silence might not mean no one is out there. It might mean the smart civilizations learned that being noticed isn't a prize. Because if contact ever happens, history suggests it won't be a handshake. It'll be an event we spend the rest of our existence trying to survive the consequences of, assuming we get that long. Story 26. The meteor that struck the Yucatan Peninsula and caused the extinction event that killed the dinosaurs detonated with more force than all the nuclear weapons on Earth combined. The fact that it hit the sea caused 3-mile-high tsunamis, and the force of the blast momentarily sent the atmospheric temperature to 1,800 degrees Fahrenheit. The temperature was a few hundreds degrees for a few hours after that, cooking everything above ground. If you were unfortunate enough to be caught in it, you could see the sky literally on fire. The blast hit limestone and other stable things, but those aren't meant to be turned into a gas and hurled into the atmosphere. At first, burning chunks fell from the sky, then the thick material blotting out the sun formed clouds. What followed was acid rain. Not industrially polluted rain that we call acid rain, but straight up sulfuric acid. Maybe it's not the most impressive force in the universe, but the effects are terrifyingly local. This event did allow for the evolutionary rise of mammals and eventually us. But the next time it happens, we'll be the animals that get wiped out. Story 27. Honestly, that's the most grounded take in the whole thread. Cosmic horror is abstract. Gamma ray bursts, black holes, vacuum decay, those are clean, impersonal. If they happen, you don't suffer socially. You don't get betrayed. You don't get hurt on purpose. Physics doesn't hate you. It just doesn't care. People are worse. The truly terrifying stuff in the universe isn't light years away. It's what humans do to each other when given fear, power, scarcity, or an excuse. Genocide, torture, cruelty done slowly, deliberately, face to face. Things planned, justified, repeated. No alien invasion has ever matched the creativity humans bring to hurting one another. At least cosmic disasters are honest. And then there are spiders. They don't need a grand theory. They're just wrong. Too many legs, too many eyes. Movement that bypasses your brain and goes straight to panic. They appear silently. They wait. They exist in your space without asking. Evolution looked at them and said, yes, this is fine, which feels like a threat in itself. So yeah, forget the end of the universe. The scariest things are already here, already proven, already crawling around your house or walking around in human skin. The cosmos might erase us someday, but humans and spiders, they don't need infinity to ruin your night. Story 28, your reality, or maybe not your reality, is all you will ever know. You are practically all that matters, but nothing any of us do actually matters. I could just be in a deep sleep right now, or a virtual reality, or a simulation. All of you could be surveying me for some elaborate plot. To sum it up, how little I, or any of you actually know. We just kind of go about our meaningless lives doing unimportant things to just occupy time in our short life. Nothing makes sense. So many things I cannot possibly comprehend. Story 29. This one is quietly existential in the worst way. The idea comes from something brutally simple. Finite combinations. There are only so many ways atoms can arrange themselves in a given volume of space. A square meter, a human body, a brain state having this exact thought. The number is unimaginably large, but it's not infinite. So if the universe is infinite, or even just big enough, patterns must repeat. Not metaphorically, literally. Far enough away, so far that distance stops being intuitive, there could be another Earth, another solar system, another you. Reading this, having the same realization at the same moment, same scars, same memories, same fear when this thought lands. This isn't sci-fi hand-waving. Physicists like Max Tegmark have argued that in an infinite universe governed by uniform physical laws, repetition isn't just possible, it's inevitable. Given enough space, probability stops being a comfort and becomes a guarantee. What makes this unsettling isn't that you're not unique, that's manageable. It's that your life might not be singular. Your choices may already be mirrored elsewhere, not in another timeline or dimension, but right now, in the same universe, playing out identically until some microscopic divergence splits the paths. There's no connection, no awareness, no meeting, just copies scattered beyond any horizon you'll ever reach. You're still you. Your experiences still matter to you, but the universe may be so vast that even identity becomes a pattern, and you're one instance of something that happens again and again simply because there was enough room for it to happen. Not destiny, not fate, just statistics, given enough space to work. Story 30. That idea is terrifying in a way that sneaks up on you. On one hand, death feels absolute. You end, and then there's an infinite amount of time where you don't exist. No dreams, no darkness, not even nothing, because nothing still implies experience. Just absence. Eternity passes without you in it. But then probability creeps in and ruins the comfort of finality. Given enough time, absurd amounts of time, structures reform. Matter rearranges. Intelligence evolves again. And if the universe is large enough, old enough, or strange enough, then the information that once made you isn't sacred or unique. It's just a configuration. One that could, in theory, be reconstructed. Not by magic. By being so advanced they treat dimensions the way we treat files. Godlike only because of scale and patience. They could rebuild you atom by atom or reinstantiate your mental state in a substrate that didn't exist when you died. From your perspective, there's no wait. One moment you're gone, the next you're walking down a street, sunlight on your face, convinced you just had the strangest dream. That's the part that bends the mind. Eternity could pass and you'd never feel it. And then subjectively, now resumes. Death wouldn't feel like an ending. It would feel like a cut in a film, edited by a universe that never promised continuity, only possibility. Maybe nothing happens after death. Or maybe the scariest option is that something eventually can, and you don't get a say in whether you're called back.